Hi guys, welcome to Algorithms Made Easy. In this video, we'll see the question Search in a 2D Matrix Part 2. As you can see, there are many likes on this question, and so this is one of the most liked questions from Leetcode. So let's just go ahead and see what this question means and how to solve this particular problem. We need to write an efficient algorithm that searches for a target value in m cross n matrix that is given to us, and this matrix has the following properties. Integer in each row and in each column are in ascending order from left to right and from top to bottom. So over here we need to find the given target is present or not. If it is present, return true. Like in this case, we return true, and if it is not present, like 20 is not present, we'll return false. So how can we solve this question? One of the basic brute force approach would be to iterate over the matrix and to check whether we find a target or not, and that would be of a time complexity of m cross n, that is searching for the whole grid. Now how can we reduce this time complexity? Let's go ahead and see that approach. So let's take this particular matrix, and with that we'll be searching 20 in it, and as you can see there is no 20 present in this matrix, and so the answer should be false for this particular question. So over here, for the approach that we are using, we can start from any of these 2 points. Now why not these two? We'll see this, or we'll get to know this when we are done with the approach that we are following using any one of this point. So let's use 15 for our purpose. Now since 15 is less than 20, we can say that this first row is not of use for us because it contains all the elements which are less than 15. So what we can do is we can move one step ahead by moving down in the matrix and eliminating this first row. Now we have 19, which is again less than 20. So again this row is of no use to us and we can move down. Now comes 22. Now 22 is actually greater than 20. So what you know is that all the elements after 22 in this column would be greater than 22, and so these are of no use to us. So we can move inwards and go to 16 from here by eliminating this particular column. Now 16 is less than 20. So we need to go one row below as this row is of no use to us. So we'll go down, and again 17 is also lesser than 20, and we know that this particular row has all the elements which are less than 17. So we'll go down. Now 26 is greater than 20, so we'll move to our left or inwards. So we go to 23 and check for that particular value. Now suppose our search value would have been 23. So we would have found 23 and we would have returned true. But for our case, 20 is still less than 23. So we need to move inwards, and so we move to 21. Now again 21 is greater than 20. So we'll move again to our left. And here now, since 18 was actually less than 20, we would have moved down, and that would make our cursor out of range. And that's where we end and say that we have not found the value, and so we can return false in this case. So here, what is the time complexity? The time complexity over here would reduce from row multiplied by column to row plus column, because here we have seen that we haven't found the value, and the maximum iterations that we have done are we have iterated over all the rows once and over all the columns once, and so that would give us row plus column time complexity. Let's see what would have happened if we would have iterated from 1 or 30. To find 20, if we start from 1, we know that it is higher than 1. So in which direction do we go? Do we have anything that we could eliminate? In this case, we could just eliminate 1, as all these values are still valid for our search area. So there is no way we could eliminate an entire row or an entire column elements. Similar would have been with the case if we have started from 30. All the elements in this matrix except 30 are less than 30. So these are all the valid candidates for searching, and so we cannot eliminate a lot of values, and so we cannot start from 1 or 30, but we could have started from 18, and the same logic would have been applied. Instead of going down, we would have gone up, and instead of going to left, we would have moved into right. So what are the conditions that we need to take care of? So there are two conditions. If the target was greater than the pivot, that is, while we were at 15, the target was greater than pivot, so we did a row plus plus. And when the target was lesser than the pivot, for example in 22, we did a column minus minus. So that's the only condition that we need to keep in mind in order to solve this question. It is a really interesting approach. So now let's go ahead and quickly code this out. So over here, first we need our starting position, which is the top right corner. And then we'll loop while my row is not going beyond the row dot length and my column is not going beyond 0 in the negative direction. In that case, I'll be applying the logic to increment the row and decrement the value as we have seen in our example. So firstly, we check whether it is a target value. If it is, we can just return true, or else we can go ahead and increment the row or decrement the column as per the condition. And finally, if this while loop gets terminated without returning true, we can just return false. So that's it. Let's try to run this code, and it runs successfully. Let's submit this, and it got submitted. So the time complexity for this particular approach would be row plus column as we have seen in our example, and the space complexity is O of 1. So that's it for today, guys. This is the important question from the interview rooms, and so I hope you guys liked it and understood it. I'll see you with another video. So till then, keep learning, keep coding.